Hi everyone, welcome to another MES industry conversation. I hope you're keeping well, and I know this is a stressful time for us all. In particular, those trying to find work experience in graduate jobs, as well as preparing for our exams. So make sure you're keeping up to date with MES while at home. You can do this by signing up to our newsletter, which is linked below, as well as following us on Facebook. We're here to serve you as best we can, so make sure you're making the most of the opportunity. Today, we're focused on energy, and we have Simon joining us from AGL. Simon studied a Bachelor of Mechanical Engineering and Law at Melbourne University and graduated in 2011. Throughout his time at university, he completed an exchange in Vancouver, as well as completing several voluntary internships. He was also involved in the Formula SAE team, or MUR. Simon secured his first full-time paid summer internship with Shell at Geelong Oil Refinery after his penultimate year, and then spent the next 2 years working at Geelong for Shell. Simon then moved back to Melbourne and worked in the Altona Refinery at ExxonMobil for 5 years. Now, after deciding he wanted to branch out of oil and gas, he started studying a Master of Energy and Resource Law at Melbourne University part-time to upskill his background and differentiate himself in the job market. Simon made a career change to the Victorian State Government in 2018 and subsequently followed a role with AGL in the Renewables Energy team. He is now currently responsible for overseeing the reliability and maintenance of AGL's 9 wind farms and 2 gas turbine facilities. Yeah, I'm keen to start off with your current role at AGL. Maybe you could start by just explaining a little bit about your current role and what the role is of mechanical engineers more broadly in AGL.
Yeah, definitely. So my title is Senior Mechanical Engineer at AGL in the Wind and Solar team, and I pretty much look after the reliability and maintenance of all of AGL's wind farms across Australia and their solar farms, but there's not really anything mechanical in the solar farms. And we've also recently just had put into our team the Somerton gas turbines, which are in Tullamarine. So that's a bit of backup power that we're also utilising when the wind's not blowing. And as a mechanical engineer within this role, you're playing a kind of support role to the operations team. So the operations team do the day-to-day running of the wind farms, and then as a mechanical engineer, if there's anything mechanical that they're having issues with, they call you up or they communicate with you, and then from there you provide some support, you do some background investigation, root cause analysis, materials investigation sometimes, and pretty much just sort out the problem or the issue or provide some advice. And so within this role, you're pretty much just tracking the amount of wind turbines that are down, and your role is to minimise the amount of wind turbines that are down at any given time, and that's more of a reliability focus. And then beyond that, there are a few improvement projects. So where you can identify benefits within the wind farms and wind turbines themselves, nominating them for a business improvement is part of the role. And we've done a few things like review the accuracy of wind vanes, and currently rolling out a project to install an upgraded wind vane. And then there's also some other things on the wind turbine blades, but there are a few improvement items that we're working on, and often you engage a lot of consultants who actually do the background work and checks for you, and you as a mechanical engineer are often presenting the business case.
Cool, that's really interesting. When you start looking at a potential wind farm, does the collecting of data of wind start well before you think about purchasing a plot of land, or you start looking into it? Like, is the Bureau of Met or someone helping you to gather wind data so that you can work out, what's our value that we've got here?
Yeah, good question. And that's maybe where I'll unpack sort of where a wind farm sits in terms of design, and then also operation, and then pretty much decommissioning. So pretty much from the scoping phase or the feasibility phase, there is an incredible amount of research data that goes into that, and they call them met masts, which are pretty much just tall structures that measure the wind at a certain height. And once you collate all that wind data, you can then essentially you look for a bit of a tender for a wind turbine design. And that's so AGL doesn't actually design wind turbines. AGL is a wind turbine operator. So we rely on the expertise of the wind turbine design or wind turbine companies. And so those companies are Vestas, General Electric, GE, fabricate them. And then there's a few others in the market, Suzlon, which is actually an Indian company. And we work with them to give them a data set, and then they can kind of come back and work with us on which turbine would suit best and the amount of turbines we want, because the more turbines, the more power output. But whether you want more power output or not depends on the market. So there's a whole lot of inputs into that scoping phase. And myself, I'm not involved in the actual scoping or project phase. So I'm in the operations team at AGL. And I guess that's a distinction between, whether you're looking to work on projects or looking to operate the assets. Both have different challenges, because building a wind farm's different to operating a wind farm. To break it down, challenges are a bit different. So there is a lot of data and research that does go up front into that design. But at the same time, there's still a lot of uncertainty around it. And depending on also the density of the amount of wind turbines you want to put on a site. So you can put them really close together and not need as much land, but then there's a risk that what happens is the wind may have this wake factor where it will hit the first turbine, but then the wind quality won't be as good for the other wind turbines because it'll be turbulent, and therefore you're not going to get the same amount of power from the wind turbines that are downstream rather than the ones that are upstream of the wind. So the density is another factor. There's a whole lot of competing factors that go into that equation, and there's no right answer. It's more so where you draw the line and what your preference is and what your goals are within the project. And even the construction of a wind farm, taking these blades out to the middle of nowhere is a huge logistical exercise, and planning them to come into different ports and other things like that. The construction phase, there's a lot of civil engineering work, so that primarily suited the civil engineers for building a lot of steel structures and things like that. But I have some mechanical friends that have done projects and they've had no issues with it. I think it's more so just that continuous learning mindset in those jobs.
In terms of the office, how many people would have mechanical backgrounds as opposed to sort of civil and electrical? You'd assume renewables comes from a mostly sort of civil and electrical background, but it clearly is a role for a mechanical engineer in a renewables company.
Most of us are electrical and mechanical, but the further you sort of go up into management, the more it's focused on your decision-making abilities rather than your background. There's not too many civils in the operations team. I don't actually know the projects team background at the moment, so we're doing a little bit of work with them. But mechanical and then a lot of electrical at the moment. The electrical is pretty important due to the amount of work required for connecting to the grid, and then also managing a lot of the electrical equipment on site, the transformers, the switch yards, and particularly because renewable energy is a variable energy source and it's non-synchronous. So I'm not quite sure the background of a lot of people, but there's a lot more challenges with supplying to the grid when you're a non-synchronous generator. And this is where wind turbines and wind farms differentiate from your classical coal-fired power stations, which generate these large steam turbines. There's a lot of mass behind that, which puts a lot of inertia into the grid. And therefore, with the wind turbines, you don't have that mass behind it. And it's something I'm still trying to understand myself on how they balance the grid. But as an electrical engineer, it's really important, really critical to our site. And as a mechanical engineer, you're just as important to keep the turbines running, and you play that role just as much as the electrical engineers. But I think for me and for my benefit that I'm trying to work on now is understanding that electrical side of things. And that's where some advice for some people looking to get into that is, if you are mechanical, try and learn a bit more about electrical. And if you're an electrical person, try and learn a bit more about the mechanical side. I think and understanding all this, you can do a lot of this at university with the clubs and societies, or even just public lectures. I think the Melbourne Energy Institute is one I mentioned previously, but that's where I've done a lot of my learning actually about industry from different perspectives there, going to those lectures. And I actually still go to some of those lectures because there's a lot of people in industry that talk at those lectures. I think it's more focused on the Masters of Energy Systems. I'm not too sure what everyone's background is here, but that's, something you can go to for free, those sessions as well. So yeah, always looking to kind of gain some skills. There's some online information as well you can find through, looking at the market operators. So the Australian Energy Market Operator has some pretty good information on how the grid operates and how they manage supply of things like renewable energy. So understanding that on a wider scale is pretty important.
Students are always sort of asking for a project that you've worked on that might be, I guess, relevant, or you had to use your mechanical engineering background or something like that, and how you overcame the project. That, I guess, tells us a little bit more about your role.
The one I'm currently working on is the wind vane project, and that was interesting because I had to go back and do a fair bit of programming. I don't know how much programming is taught, but I did one subject on Introduction to Programming in C, now trying to configure or write a script in Python. So programming is one of those ones that's great for data analytics. So that's another skill that's worthwhile. And that's not so much mechanical engineering, more computer science, I guess. But the other mechanical side of things, maybe just a safety, a lot of safety stuff when you're doing design of things like equipment such as anchor points. It's something pretty simple. So the anchor points are something you clip onto with your harness, and then the idea is that it needs to take a certain amount of load for you to not fall, for it to fail, and to catch you as the last resort. And so we've done a lot of testing of these anchor points. We had one fail due to a material failure, and you've got to do a lot of analysis on, I guess, materials pretty much. And I've done a lot of that in my background in oil and gas, actually, and that's where it's kind of been a strength to know the vulnerabilities of stainless steel to carbon steel to other alloys, and know sort of what contaminants can crack them and corrode them. And in this instance, stainless steel is vulnerable to chloride stress corrosion cracking. So a little bit of chloride and some water, and then a tensile stress can lead to stainless steel cracking. And we had these occur on some anchor points on wind turbines, and they're a critical safety component. So yeah, we did a lot of first principles stress analysis on these anchor points, and did a lot of testing at a facility in southeast of Melbourne. And that was an interesting kind of using base principles scenario, and then using an exact force, which is 21 kilonewtons on this little steel anchor point was interesting. So yeah, I think that's probably one project. I think that's very inspiring. I think it's the other stuff with data and wind is probably a bit more inspiring at the moment.
And you seem to be sort of specialised in materials from, I guess, your work. Looking at your work at previous work in oil and gas, you're involved in material and sort of reliability, corrosion. Tell us a little bit about that experience and what led you to sort of be interested in being involved in materials. Was that something that you were interested in at university, or is it something that's developed through work?
Mainly just through work. When I first started at Shell, they had kind of materials or fixed equipment and rotating equipment, and I was started off in fixed equipment and materials, but it's actually not a lot of the work I do at the moment. So I think just in the examples I gave were materials, but there's a lot of rotating equipment. So I think within industry, there's probably two main areas with materials, which is fixed equipment and then rotating equipment in the mechanical realm. And yeah, I started off at Shell at the Geelong refinery and did a lot of work in materials, which is a great background to have because everything's made from different materials, and understanding material properties is important. But for me, it was important to branch out as well, and that's where I've done a bit in terms of just managing maintenance programs, which is more of the rotating equipment. And then moving into wind turbines, it's actually a lot of it is rotating equipment as well. So I think the blades is materials, and some of the structure is materials, but all the moving parts within it also have to support as well. So I think for me, it was a bit of a challenge starting off in materials, and I did see that I didn't want to get pigeonholed too much. Some people may enjoy that area and stick with it for life, which is kind of where you become a technical specialist, if you like. But for myself, I wanted to sort of branch out and be more general and move into, I guess, a bit more sort of management in terms of managing maintenance programs rather than being the expert. And so yeah, I've had to have a bit of a balance. I did start off in that materials field, which is really good. I recommend, if you're starting off somewhere, to really dive into it, because all the expertise and all the knowledge you learn in one area is always transferable to another area as well, because all the rotating equipment all has material properties that you're studying anyway, and all those material properties are really important for all the analysis you do.
Yeah, for sure. And I guess there is a bit of I guess you do get a different skill set at AGL, and you did have to go through a bit of a career pivot before that, as you mentioned. Can you talk us a little bit about your move from Exxon and back to university, and then into a sort of new career path?
I think people need to get used to change a bit more in this day and age. I think we're moving beyond that path where you can stick one career or one job or one company for life. You sort of have to keep an open mind. And I think I experienced that to start off with, actually, in sort of the second year at the Geelong refinery, when Shell said they're selling the refinery, and that was a shock to a lot of people, but it's still operating, and it's changed owners, but that's kind of part of business now. And then, I did move to the Altona refinery for a few years, which was more stable with ExxonMobil. But I just knew that the industry was changing and it's not a growing industry, and I wanted to move into something more sustainable. So I was studying part-time. I'm actually still completing the master's. I think you need to still have a bit of continuous learning about you, and always looking to sort of look at what the next thing is in industry. And the master's was a Master's of Energy and Resource Law. So through the law school, it was something that I saw myself as differentiating myself against other peers in industry, and then also being able to be focused on the energy industry, which is what I wanted to move into something more sustainable. And that just allowed me to get a better feel for the market and what AMO is doing and what the operators are doing in the market and what the regulations are and things like that. So I think it's important when people are looking at courses, looking at masters, looking at what the next form of study is, to make sure you look at the content of what's being taught. I think a lot of people like to follow titles, and there's a lot of people that prefer or like to do the MBAs. But if you're looking at further study, and obviously the masters, what you're doing now, just make sure you look at what content's in there and who's teaching, and whether that can be help develop you, or whether you're just doing it because it's Melbourne University and that's the title of it. So it was a bit of a balance. And I think when you mentioned the pivot, I did work in state government for 6 months, and that was a bit of a risk. So as well as being used to change, I think sometimes you do have to take a bit of a risk. And it was a bit of a backward step in my career in terms of security, and it wasn't a long-term contract. And that opened up some doors into AGL, which has provided me with a permanent role in the renewable sector, which was my goal in the end. So that's worked out. And I think the other thing is for graduates to just be patient sometimes. It's taken me a while and taken me a few years, taken me probably a lot longer than I expected to find a role in the sector. But I think really making sure you're developing those skill sets that can put you in the industry in future is probably the key thing to learn along the way.
Thanks for that insight. And I guess going back even further, you did a engineering and law degree, and I think that's something I've never seen before. So what was the sort of decision making around that?
There wasn't too much thought into it. It was more so that I did a lot better in high school than I thought, and this was before the Melbourne model, so you could do the double degrees. And I just took the opportunity while I could. And at the time, it was a pretty poor choice, to be honest. I kind of struggled in the law faculty for a while, but it did create a skill set, or a ticket that differentiated me amongst others, I think. And that's something that you do need to kind of think about, because I think as mechanical engineers, everyone often does the degree straight, and often mechanical engineers have their blinkers on and are very focused on just their maths science people, and that's it. Whereas it doesn't need to be a law degree. It can be anything. It can be a skill set in programming, like I was mentioning before. That's a really worthwhile skill set that can differentiate you. It can be working at a mechanic. It can be another leadership role that you have in a club or a group or a volunteer organisation. But yeah, I think having something that can differentiate you does get you a ticket into interviews and things like that, which is important to think about. And unfortunately, there's only a certain amount of graduates and jobs, so you do have to think about things or skills along the way that are beyond just doing the degree.
If you could go back and I guess if you had some advice for yourself when you were in your engineering degree, and especially now with most of people listening are in sort of, they might be going into their master of mechanical engineering, or they might be preparing to leave mechanical engineering and are looking at different fields and can't quite decide what they want to get into. Is there any advice you have for them around maybe what they could be looking into? I know you mentioned some of it before around looking for other things to add on to your degree, like going to public lectures and that sort of thing. But is there any other sort of advice you have for students that are preparing themselves for their future careers?
Yeah, I think it's an interesting one. I feel like the word career is changing a lot, and it's becoming more dynamic in the job market these days. So yeah, I think I've probably mentioned a lot along the way already, but in terms of what I noted down was, get involved in those things that are more than just the classes. There's plenty of clubs and there's public lectures where you can speak to people in industry. The Melbourne Energy Institute's great for that. There's a lot of short courses at university where you can gain some different skills. Data analytics is one that we're doing in our company quite strongly, and it's something I've had to go back and relearn a bit. And even a language, in German's a great engineering language. There's a lot of great engineering companies based out of Germany, so there's a lot of options, but you need to kind of think about more than just it's the marks, and also showing a lot of companies are really big on being able to exhibit your values and beliefs and culture. Like I think companies have really started to switch onto the fact that it's more about how the person fits in the company. And really what they're saying is, can they work in a team and can they work with different people from different backgrounds? So that's where joining clubs and being involved with different people shows you have that ability to kind of deliver something where you may have different interests, different priorities and things like that. Because I think work is often not too different from a lot of those environments, and even university, where you may not like the lecturer, you may not get along with your boss too much, but you have to make it work and you have to enjoy it. And, you have to really work with that relationship to get a result. And that's kind of the way work works. Some have more idealistic positions than others. But I think if you're studying mechanical engineering, it's a great start. I think, you can always move around to other things with mechanical engineering. So I'd really encourage people to see through the mechanical engineering. And in terms of those skills I was talking about, so some things I did, I joined the Formula SAE team. I didn't really have any motorsport background, but I just could see it was a really interesting project. And you can go and volunteer in these things, and they need all the help they can get. And you may not be the person who's doing all the fine tuning of the engine or driving the car, but if you're showing that you can replace wheels or something like that, I think sometimes I was even just buying lunches for the drivers. If you can show you can deliver on a project like a race car and things like that, and contribute to some degree, that goes a long way. I don't want to single out one thing per se, but I guess to all those guys in clubs and groups who are struggling at the moment, that's going to be great examples for you when you go into interview and they go, when did you have an issue and how did you resolve it? So, I think try and at least see the light at the end of the tunnel a bit with these problems, particularly working online, and maybe think about something you can do that would show you're showing initiative and being able to kind of pull something together for the end of the year. Yeah, there's plenty of other projects and things, nowadays everyone's screaming for rooftop solar. Is there like organisation or a group that you could install rooftop solar somewhere just as a community project at the local council or something? I'm just sort of brainstorming at the moment, but I guess it would be good to kind of sow the seed for a lot of other engineers and people. Yeah, and I think for me, just sort of pulling it together in terms of a career, for me, I don't think there's really any silver bullet. There's no real one answer for a lot of people. And I shy away from people trying to get their dream job because at the end of the day, work's always going to be a bit of work when you're working with other people. You just want to more so set your priorities and set some clear goals for yourself within what you'd like to get out of work. As mechanical engineers, you like to get a bit of intellectual curiosity into some sort of design aspect, but you're not going to be designing things all the time. And I think it's important to kind of have a balance within your life and continue to have things where you can develop your leadership outside of work or inside of work, depending on how well work is going. I think work and career are kind of up and down a lot along the way on that trajectory. So yeah, I think you need to build some resilience, and at the same time, you need to enjoy the journey a bit, and you guys need to enjoy it studying the masters, because sort of look back now and thought I was really busy in my masters, but now you kind of have to work full time, and yeah, you don't have that freedom and flexibility as much. So I feel like undergraduate students get that a lot. And so I won't harp about that too much. But you see, some people have this idea where they think, oh, once I graduate, I'll finally be happy. And I think you really need to kind of enjoy what you're doing at the moment. And yeah, because you're not going to finish the degree and the world's not going to suddenly open up for you. It's going to be, you're going to have to find out how to get a job, and then work will kind of be the same thing. You have to settle into it and work on the next thing. And there's kind of, I think it's important to enjoy the year and work out what you enjoy, and then try and find that in a job. Yeah, I think that comes to kind of the last point, is to just have an open mind. I think a lot of people sort of set themselves a goal and set themselves something they really want to work on and do. And, when they don't achieve that, sometimes it can be quite disheartening, but there's lots of different ways and to get involved in different industries, and lots of pathways out there. So yeah, kind of look at the content rather than the title of a job.
I think it's be relevant to a lot of students at the moment. They might be struggling with university, or they might be concerned that they're not going to get their dream job as the first job out of university. But as you even say before, that the market's changing a lot in terms of careers, and people have to be adaptable to new careers, and there's always abilities to change throughout that. And just, yes, right, you're right, setting yourself goals will help you get you there eventually.
Yeah, and I think in these times, it is pretty important just to kind of reflect on that and realize that there will be things you'll have to do a little bit differently, and it's not what you expected to be your year to be like, but how you can adapt to that will kind of show your worth pretty much. If you're being proactive and having those communications with lecturers and university and things like that. I mean, we did mention it's kind of tough with the exams, not knowing how they're going to set them up. But I'm sure if you keep communicating with the lecturers and professors and asking what the best path forward is, you'll get through it. And at the end of the day, it's a mark, it's a grade as well. I think all the employers know the situation, particularly with universities, so they're going to be interested to know how you handled it. They're going to be interested to know what you did. Maybe it's an opportunity, if you're working at home, you can take on something else that's more local and help out local communities somehow. Showing you have that mindset is more important than the actual grade, in my opinion. And yeah, I mean, that's being shown in industry a lot, where people are recruiting all over. You don't have to be at Melbourne University now to get a job. A lot of people from RIT and all over, but they just showed the right culture fit and the right skills that they had and willing to apply themselves. So yeah, it's important to keep that in mind and keep that perspective. So yeah.
Thanks so much, Simon, for all your insight, and I'm sure students will be really receptive to this area, and especially those ones that are interested in getting into the energy sector more broadly.